Good morning. In this lecture video, I'm going to explain latches. So, as I explained in the previous video, basic bistable element. So, which is uh, consists of cross-coupled NOT gate, a stable in two stable state. So, from the basic bistable element, we construct the latches. Again, it is similar for common to both electrical and electronic students. So, latches. Again, it is a storage device. So it forms a one class of flip-flops. So means flip-flop means there are different classes of flip-flop. Latches is one class. Edge triggered flip-flop is another class. Master slave flip-flop is again another class. So mainly we call flip-flops are edge triggered. Okay. So timing output changes is not controlled. That means whenever the input changes, output will be affected. And output responds immediately to the changes in input lines. Although a special control signal that is called clock or enable is present, output changes immediately after the changes in input whenever the clock or enable signal is enabled. Thus, input lines are being continuously interrogated. That means inputs are keep on monitoring. Whenever the changes occurs, output will be changes. So let's see the differences between flip-flop and latches. So latches here, timing of the output changes is not controlled, but here it is controlled. So inputs are continuously interrogated, but here normally sampled, but not continuously interrogated. Here setup and hold times constraints are not present, but here it is present, right? And changes in the inputs are affect the outputs whenever the control input is 1. But here, whenever the transition occurs, that means either 1 to 0 transition or a 0 to 1 transition. So hence, latches are called level triggering and flip-flops are called edge triggering. This is the main differences between latches and flip-flops. Now let's see SR latch, mean set reset latch. It consists of cross-coupled NOT gate. This is the circuit diagram. Cross-coupled NOT gate. Remember here, R corresponding to Q output and S corresponding to Q bar output. So, as we know, NOR gate can be replaced with R followed by NOT gate. This is the second structure. Same thing. So here, NOR gate is replaced with R and NOT. And this is the logic symbol. IEEE logic symbol. So here it is Q bar, but here it is Q, but output bubble represent complemented. So SR latch consists of S and R inputs, Q bar outputs. Logic symbol. Okay. So this is what the truth table that we are going to verify as an operation. Okay. Now let's verify the operation. Uh, Yeah, it consists of cross-coupled NOR gate. It has two inputs S and R, referred as set and reset, and two outputs Q and Q bar. So from the second logic diagram, when both S and R is equal to 0, diagram simplifies to basic bistable element. That becomes a cross-coupled NOT gates. Because so whenever one input to the OR gate is fixed to 0 and output of OR gate is depends on other. If other input is 0, output is 0. If other input is 1, output is 1. So that is why it becomes cross coupled NOT gate. Clear na? So here Q denotes present state. Present state, and that means what is the value present here before input changes occurs. Before input changes occurs. That is the state at the time input signals are applied. And a response of the latches at Q and Q terminal as a consequence of applying inputs denoted by Q plus bar. That means so when you apply the inputs, changes will happen. So that is denoted by Q plus bar. So Q is the present state, Q plus is the next state. this q plus is called as next state of the latch. Now let's verify the operation and we complete the truth table. Okay. So case 1, when s is equal to 0, r is equal to 0. S is equal to 0, r is equal to 0. So we'll get a next state same as a present state. Now we'll verify that. So we don't know what is the present values. Assume present values, that is q is equal to 0, then q bar is equal to 1. Okay. So when q bar is equal to 1, that is connected to uh, lower NOR gate. Okay, sorry, upper NOR gate. Q bar is equal to 1, no? Upper NOR gate. So whatever may be other input, its output is 0. Because one input to the NOR gate is 1, its output is 0. So output of upper NOR gate is, that is Q is equal to 0. And that, since inputs are R is equal to 0 and Q bar is equal to 1. Okay, then output of lower NOR gate becomes 1, that is Q bar, because inputs are S is equal to 0 and recent Q, Q is equal to 0. So when both the inputs of the NOR gate is 0, output is 1. So same as present state. So we assumed Q is equal to 0, Q bar is equal to 1. We got Q is equal to 0, Q bar is equal to same as present state. If you assume Q is equal to 1, Q bar is equal to 0, again output of lower NOR gate Q bar is equal to 0, because inputs S is equal to 0, Q is equal to 1, and then output of upper NOR gate is 1, because both R is equal to 0, Q bar is equal to 0. Both the inputs R is equal to 0, Q bar is equal to 0. Output is also same as present state. Means whatever we assume, same thing we are getting. So next state is same as present. If it is Q is equal to 0, Q bar is equal to 1, we get a Q is equal to 0, Q bar is equal to 1. If it is 1 0, we get a 1 0. So that is why it is indicated as Q is equal to Q plus is equal to Q plus bar is equal to Q bar, same as present state. State is present state. Clear now? And next, so we'll verify for S is equal to 0 and R is equal to 1. S is equal to 0, R is equal to 1. Here R is equal to 1 now, which is connected to upper NOR gate. So regardless of second, so no need to assume the what is the present state. No need to think about the present state. Since R is equal to 1, which is connected to upper NOR gate, whatever may be other input, output is a 0. So regardless of second input, output of upper NOR gate Q is equal to 0, since R is equal to 1. Then input to the lower NOR gate becomes Q is equal to 0, S is equal to 0. Then its output is 1. Q bar is equal to 1. Correct? So if S is equal to 0, R is equal to 1, then Q is equal to 0, Q bar is equal to 1. So reset, latch being reset. See? Again, now if R becomes 0, that means both becomes 0 0. Now the value is Q is equal to 0, Q bar is equal to 1. So output of inputs to the upper NOR gate are R is equal to 0, Q bar is equal to 1. Its output is 0, and that is connected as input to the lower NOR gate now. So lower NOR gate is Q is equal to 0, S is equal to 0, so its output is 1. Okay. So Q is 0, Q bar 1. So same we are getting now. Yeah. So when S is equal to 0, R is equal to 1, it enters into a reset state. And now when R becomes 0, both are 0 0, same present state we are getting. Okay. So S is equal to 0, R is equal to 1 means reset state. Let's see. Here R is equal to 1 means R corresponds to reset state. So it enters into reset state. That is Q is equal to 0, Q R is equal to 1. And we go for third case, both 1 0. So when S is equal to 1, R is equal to 0. So S is equal to 1 means it is connected to lower NOR gate. So regardless of second input, output of lower NOR gate Q bar is equal to 0 since S is equal to 1. Then inputs to the upper NOR gate, R is equal to 0, Q bar is equal to 0. So then its output is 1, that is Q. So when S is equal to 1, R is equal to 0, Q becomes 1, Q bar is, that means latch being set. Based on the value of Q, we say set or reset. If it is 1, set. If it is 0, reset. Again, if now S is equal to 0, S becomes 0, right? So Q is equal to 1, Q bar is equal to 0. Q is equal to 1, which is connected to lower NOR gate. So inputs to the lower NOR gate are S is equal to 0, Q is equal to 1. So its output is 0. Q bar is equal to 0. Same thing we got. Again, this Q bar is equal to 0 is connected to upper NOR gate. So inputs to the upper NOR gate, Q bar is equal to 0 and R is equal to 0. So its output is 1. So same as present, no change. So when S is equal to 1, R is equal to 0, Q becomes 1, Q plus 1, Q plus bar is 0. That means set state. So last case, when both are 1, 1. When both are 1. See, when both are 1, 1, both outputs are forced to 0. Outputs of both the NOR gate becomes a 0. That means Q is equal to 0, Q is equal to Q bar is equal to 0. So they are not complementary. They are not complementary. So and difficulty is encountered when both simultaneously returns to 0. I mean, it is difficult to analyze when both simultaneously becomes 0. Suppose if one becomes 0, we can analyze. We can analyze. See, suppose now S becomes 0, R is still 1, and Q is equal to 0, Q bar is equal to 0. So since R is equal to 1 now, it is connected to upper NOR gate. So output of upper NOR gate is 0 since R is equal to 1. Then inputs to the lower NOR gate, S is equal to 0, Q is equal to 0. So its output is 1. So it enters into a reset state. Reset state. Clear na? Thus latch being reset. Similarly, if R becomes 0, S is still 1 and the value of Q bar is 0. Since S is connected to lower NOR gate, output of lower NOR gate Q bar is equal to 0 and that will be input to upper NOR gate. So upper NOR gate inputs are R is equal to 0, Q bar is equal to 0, then its output is 1. Latch being set. Proper operation we are getting. If either of one becomes a 0. If both becomes 0, it enters into metastable state. So that is why we call it as a forbidden state. Forbidden state, that is 0 star 0 star. Since both the NOR gate forces its output to be a 0. Clear na? So if both input returns to 0 simultaneously, device may enter into metastable state and it should be avoided. And device becomes stable, but final state is unpredictable. So why? Because unpredictable, because it is based on the construction difference and thermal noise. Construction is based on difference in thermal noise. So for this reason, along with the facts output are not complementary, S is equal to 0, R is equal to 1 is regarded as a forbidden condition. So again from the table, see, whenever R is equal to 1, R is equal to 1, reset. Whenever S is equal to 1, set. So we call 1 as an activation signal of the device. Also, changes on S and R input immediately affect the output. Hence, they are regarded as asynchronous or direct inputs. So, whenever the S and R changes, output will be changes. That is why they are asynchronous inputs. Clear na? Asynchronous inputs. So, this is about operation of SR latch. So, I'll continue in the next video. Thank you. Thank you.